Number 33, while nursing, blue whale calves can gain weight at a rate of 200 pounds per day. Per is our key word. There's going to be our slope. Two particular calves weigh 6,000 pounds and 6,250 pounds at birth. Those are big babies. Write equations that model the weight of each calf as a function of the number of days since birth. So let's take the first calf. If we think y equals mx plus b, remember m is our slope, how fast it's growing, and b is our y-intercept, kind of where it begins. So calf number 1, it starts out at 6,000 pounds, and it gains or adds weight at 200 pounds per day. So 200 pounds times the number of days. Calf number 2 just starts out a little heavier, 6,250, and it gains the same weight, 200 pounds times however many days go by. So there's part A. Part B, how much is each calf expected to weigh 30 days after birth? Well, calf 1, we'll just plug 6,000 plus 200 times 30. That's going to be 6,000 plus 200 times 30. Well, 2 times 3 is 6, and then add 1, 2, 3, 0. So add 6,000. We're looking at 12,000 pounds. The other calf is going to gain the same amount of weight, 200 pounds times 30 days. It's going to gain 6,000 pounds. So if we take its original weight, 6,250, plus another 6,000, it's going to be 12,250 pounds. And then part C asks us, how are the graphs of the equations from part A related? So how are these graphs related? Well, even though they have different y-intercepts, they do have the same slope. So it doesn't ask us to graph it, it just says how they compare. So we could say that the graphs are going to be parallel because they have the same slope. But we'll just call it C2. Calf 2 will have a larger y-intercept. So if you think about a graph, just a real rough sketch, one of them is going to start here and grow, and the other one's going to start here and grow at the same rate.